Hello everybody, welcome to my lesson. We are together with polygons and there will be several videos about the section. All we need to do is stick together. Enjoy it. So we can start with the definition of a polygon. A polygon is a simple closed curve made up entirely of straight line segments. These line segments are called the sides and each point of the segments is called a vertex. So here a polygon is given A, B, C, D, E, F. The line segments here A, B, B, C, C, D, D, E and E, F. When we combine all line segments, we are going to get a polygon. So for the sides A, B, B, C, C, D, D, E, E, F and F, A are sides of the polygon. For vertex A, B, C, D, E and F, vertex points of a polygon. So vertices are A, B, C, D, E and F. So here I'm going to show you types of polygons. The polygons will have special name according to their size. For example, if the polygon three-sided, so it is called triangle. For four-sided polygon, it's quadrilateral. For five is pentagon. For six, hexagon. For seven-sided polygon, we call it heptagon. For the eight-sided, octagon. For the nine-sided, nonagon. For the 10, decagon. For 11, hentagon. For the 12-sided polygons and more than 12 sides, we can call it like and gon. The first theorem, we are going to describe what is the definition of the diagonal. A diagonal of a polygon is a segment that joins two non-consecutive vertices. So the pentagon given, five-sided polygon. So how can you find the number of diagonals without any formula? So it says diagonal joins two non-consecutive vertices. So first I will combine point A with C and D. And for the next vertex is B. B goes D and E. And C goes A and E. D goes B and A. E goes B and C. Okay, so the number of diagonal here is 1, 2, 3, 4, and 5. With the formula, how can you find this? So if the polygons are n-sided, to find number of diagonals, we are going to use n times n minus 3 over 2. And here the polygon is 5-sided, so the number of diagonal will be 5 times 5 minus 3 over 2, which is 5 times 2 over 2 cancels each other out, and we will have is just 5. So the number of diagonals here is 5. In this part we have 4 theorems and 1 definition. So let's start with the first. The sum of the interior angle measures of n-sided polygon is n minus 2 times 180 degrees. For the second theorem, the sum of the degree measures of the exterior angles of any convex polygon, one angle at each vertex is 360 degrees. For theorem 2c, the measure of each interior angle equals n minus 2 times 180 degrees over n. The last theorem says each exterior angle of n gon has an angle measure of 360 degrees over n. For the definition 3, if a polygon is both equiangular and equilateral, equiangular means that interior measures are equal, equilateral, all sides are equal. So we may call these polygons as a regular polygon. Okay, so to understand better, look at the example. Here the pentagon is given, 5-sided polygon. AB is equal to BC is equal to CD is equal to DE is equal to EA is a regular polygon. So it means that each interior measures and exterior measures are equal. So we can start with the theorem 2a. It says the sum of the interior angle measures of n-sided polygon is n minus 2 times 180 degrees. The polygon 5-sided, so what is the sum of interior angle measures? 5 minus 2 times 180 degrees, right? So we can say the measure of angle A plus the measure of angle B plus the measure of angle C plus the measure of angle D plus the measure of angle E is equal to 5 minus 2, 3 times 180, 540 degrees. Yes. For the second, the sum of the degree measures of the exterior angles of any convex polygon. This is a convex polygon. So it's always the sum of exterior measures of a polygon will be 360 degrees. So we can say the measure of supplement of A, the measure of supplement of B, supplement of C, the measure of supplement of D, the measure of supplement of E is equal to 360 degrees. By the way, remember what is the name? What is the definition of the supplementary angles? If the sum of two angles are 180, these angles are supplement. They are supplementary. Okay, for 2C, the measure of each interior angle equals n minus 2 times 180 degrees over n. We can use Theorem 2C and 2D for regular polygons. Don't forget it. Okay, for 2A and 2B, we can use these two theorems for any polygons. Okay, look at the 2C. The measure of each interior angle equals n minus 2 times 180 degrees over n. For 5-sided, so it's going to be 5 minus 2 times 180 degrees over 5. So 5 minus 2 is 3 times 180, and 5 cancels each other out. It's 36. So 3 times 36 is 180 degrees. Okay, so each interior angle is 108 degrees. Okay, let me write it first. And says each exterior angle of n-gon has an angle measure of 360 degrees over n. So for the 5-sided, it's going to be 360 degrees over 5, which is equal to 72 degrees. So each exterior measure of a regular polygon is 72 degrees. So let me extend the line. It is 72. It is 72 degrees. Okay, when we take the sum of all exterior measures, don't forget it, we are going to get 360 degrees. Now it's time to solve problems. We can put our knowledge into practice. Look at the first one. The ratio of the sum of the measures of the interior angles to the sum of the measures of the exterior angles in a regular polygon is 7. How many sides does the polygon have? Okay, so it says the ratio of the sum of the measures of the interior angles. How can you find sum of the measures of the interior angles with given n sides? N minus 2 times 180 degrees. To find sum of the measures of the exterior angles, we said that the sum of the exterior measures of any polygons are 360 degrees. It says the ratio is 7. Okay. So here we can simplify 180 and 360, 1 and 2. So n minus 2 is equal to 2 times 7. From here we are going to get n minus 2 is equal to 14. Take negative 2 to the other side. It's going to be 14 plus 2, which is 16. So the polygon have 16 sides. On the second question, we have one regular polygon. It is 6-sided, one hexagon polygon. So for the regular means that all sides are equal. Remember this. All interior measures are also equal. So we have to find the measure of angle AEB. It is called x. Okay. So remember, how can you find each interior measure of hexagon? To find this, we are going to use n minus 2 times 180 degrees over n. The polygon is 6-sided, so it is 6 minus 2 times 180 degrees over 6. 4 times 180 degrees over 6. We can simplify by 6. It's going to be 30. 4 times 30 degrees is 120 degrees. Means that each interior measure of this regular polygon is 120. So triangle AFE is an isosceles because AF is equal to FE. The sum of interior measures of the triangles are 180 degrees. So these two measures must be 30 degrees and 30 degrees. As you see here, the line segments or the diagonal EB divides polygon into two equal parts. So we say that the measure of angle FEB plus the measure of angle BED will give us interior measure of a polygon. It is 120 degrees. Okay. So the measure of BED is 60 degrees plus the measure of angle FEB is 30 plus 6 equals 120. 30 plus 60, 90. So X is 120 minus 90 degrees, which happens to be 30 degrees. It's pretty much common sense. For the next question, in the figure, points PAF and PDG are collinear triples, means that they are on the same line. If ABCD is a regular pentagon, we are going to find the measure of angle APD. Okay. As a regular pentagon, so all sides are equal, all interior measures are equal. So how can we find each interior measure of this regular pentagon? It's going to be n minus 2 times 180 degrees over n. It is 5-sided, so 5 minus 2 times 180 degrees over 5. We will have from here is 108 degrees. Let me write it. Okay, so each interior measure is 108 degrees. Okay. And we have here the straight angle, the measure of CDG, the measure of CDE, and the measure of EDP as a straight. So we say the measure of angle PDE plus the measure of angle EDC plus the measure of angle CDG is equal to 180 degrees. They are straight. So we don't know the measure of PDE. So we have to find this first. EDC, we found this. What is it? 108 degrees. Interior measure of the pentagon. Plus CDG is 20 degrees is equal to 180 degrees. From here we are going to get for PDE 108 plus 20, 128. So 180 degrees minus 128. It's going to be 52 degrees. 52 degrees. It is 52. Okay, I got it. So we will use the same method in a similar manner. It's also straight angle. 108 plus 50, 158. So to make straight, we will have here as 22 degrees. By using the property triangles, the measure of angle DPA plus the measure of angle PDE and the measure of angle PAE will give us the measure of angle DEA. So we don't know this. Let's say X. We have to find it. Okay. The measure of PDE is 52. and plus 22 is equal to 108 degrees. So x is equal to 52 plus 22 is 74. 108 minus 74 is equal to 34 degrees. Glad to have it. In the figure A, B, C, D, E, and so on is a regular polygon, and the measure of angle BDE is 120 degrees. What is the number of sides of the polygon? Okay, first we have to define this. Is it regular, right? Yes, it is a regular polygon. So it means that all sides are equal here. If all sides are equal, each interior measures are also equal. So here we will have one isosceles triangle. So triangle BCD is an isosceles. BC is equal to CD. If BC is equal to CD, automatically the measure of angle B is equal to the measure of angle D. So let's say here is X. So tell me, what is interior measure of the polygon here? 120 plus X, right? The measure of angle CDE is an interior measure of polygon. It is 120 degrees plus X. We know that in a regular polygon all interior measures are equal, so 120 degrees plus X is equal to the measure of angle DCB. So in triangle BCD, the measure of angle CBD plus the measure of angle CDB plus the measure of angle BCD is equal to 180 degrees. The measure of CBD is X. The measure of angle CDB is also X because the triangle is an isosceles. The measure of angle BCD, 120 degrees plus X, is equal to 180. So 3X is equal to 180 degrees minus 120 degrees, which is equal to 60 degrees. We can divide by 3, so X is going to be 20 degrees. The measure of an interior angle of the polygon is 120 plus 20 degrees. It is 140 degrees. The measure of an interior angle of the polygon 140, we got it. And the number of sides of the regular polygon is 140 degrees is equal to n minus 2 times 180 degrees over n. We can simplify by 20 is 7 by 29. 7 times n is equal to 9 times n is 9n minus 9 times 2 is 18. Bring it over. 18 is equal to 9n minus 7n. 18 is equal to 2n. So we will have for n is 9. So we can say we have a regular polygon with 9 sides. And here we are together with the last question. The number of question is 5. The figure constructed by extending the sides of a convex n-gon for n is greater than 4 is called n-pointed star. According to this definition, the figure at the left is a 5-pointed star. We have to find the measure of x. There are 2 ways and I would like to show you both ways. So let's start with the first way. The sum of the measures of the angles at the corners of an n-pointed star is n minus 4 times 180 degrees. N minus 4 times 180 degrees. It is for n-pointed star. It is 5-pointed star. So what is the sum of interior measure of this 5-pointed star polygon? 5 minus 4 times 180 degrees. So it is 1 times 180. It means that the sum of interior measures of this polygon is 180 degrees. So when we write the interior measures of this 5-pointed star, we will have x plus 2x plus 2x, and here the measure of angle n is 3x is equal to 180. X plus x 2x, 4x, 6x, and 9x is equal to 180 degrees. And we will have for x is 20 degrees. The second way is, we know that in triangle section, the sum of two interior measures will give us one remote exterior. So we say that the sum of 2x and 2x will give us the measure of angle NED. So it's going to be 4x, 2x plus 2x, and the measure of angle D is x plus x is 2x. And we know that the sum of interior measures of a triangle is 180. So 3x plus 4x plus 2x is equal to 180 degrees. 9x is equal to 180. X will be, again, is 20 degrees. And I think the second way has proved more useful. It is end of my video. If you have any questions, please feel free to contact me. Have a good day.